part 3 of chapter 2, lesson 3 notes is the factor theorem. The factor theorem states the polynomial f of x has factor x minus c if and only if f of c equals 0. Now to put this into terms that we understand, okay, if the remainder when using synthetic division is 0, then the binomial, and we'll call our binomial x minus c, is a factor of the polynomial. So if the remainder is 0 using synthetic division, then x minus c is a factor of the polynomial. So example 6 says use the factor theorem to determine if the binomials given are factors of f of x. Use the binomials that are factors to write a factored form of f of x. In letter A, we have the following polynomial function: x cubed minus 18x squared plus 60x plus 25. And I'm given two factors, x minus 5 and x plus 5. I need to determine whether one, both, or neither of those factors are actually factors of this polynomial. I'm going to begin with x minus 5. The first thing I'm going to do is set x minus 5 equal to 0 and solve for x, and x is equal to 5. So I'm going to use synthetic division using the number 5 outside of the division. Starting coefficients, x to the third power has a coefficient of 1, x squared has a coefficient of negative 18, x has a coefficient of 60, and x to the 0 power, my constant, is 25. When I use synthetic division, always drop down the very first term. So I'm going to drop down the 1. We multiply the number on the outside with the number at the bottom. 5 times 1 is 5. Then I'm going to add what's in the column. Negative 18 plus 5 is negative 13. Then I multiply. 5 times negative 13 is negative 65. Pay attention to the signs. 60 plus negative 65 is a negative 5. Multiply 5 times negative 5 is negative 25. When I add 25 and negative 25, I get 0. This tells me that there is no remainder. Since the remainder is 0, this means that x minus 5 is a factor of the polynomial. And we need to state x minus 5 is a factor. Next, I need to test to see if x plus 5 is a factor. So first thing I'm going to do is take the x plus 5, set it equal to 0, and x equals negative 5. I'm going to use synthetic division with the number negative 5. The coefficients remain the same, so I have 1, negative 18, 60, and 25. Bring down that first term, and then multiply. Negative 5 times 1 is negative 5. When I add negative 18 and negative 5, I get negative 23. Multiply negative 5 times negative 23, that's 115. Add 60 and 115, I get 175. When I multiply negative 5 times 175, I get negative 875. Add that to 25 and I get negative 850. My remainder, and this is my remainder, is negative 850. Since the remainder is not 0, this tells me that x plus 5 is not a factor of the polynomial. Now, once we have determined which two which is a factor and which is not a factor, then we're going to use the binomials that are factors to write a factored form. Since x minus 5 is a factor, I'm going to go ahead and list that with the polynomial that I received after I divided. Now, since I started at x to the third power and I divided by x, these are the coefficients, and I'm going to begin 1 degree less. So this will be x squared minus 13x minus 5. Now I'm looking for two numbers that multiply to make -5 and add up to -13. When I'm thinking of -5, my options are 1 and -5, or -1 and +5, neither of which add up to a -13. Therefore, I am finished, and this is the complete factored form of that polynomial. Okay, I would like for you to try letter B. Okay, pause the video. Once you attempt letter B, hit play, and we will go over the answer that you got for letter B. Okay, for letter B, first thing I did was I took my factor x minus 5. I set it equal to 0 and solved, and x equals 5. So I'm going to use 5 outside of the synthetic division. The coefficients of the polynomial are 1, -2, -13, and -10. When I use synthetic division, I get a remainder of 0. Therefore, x minus 5 is a factor. Then I took x plus 2. I set it equal to 0, solved for x. X equaled -2. That's the number I use outside of synthetic division. Coefficients are the same, 1, -2, -13, -10. And when I use synthetic division, I also have a remainder of 0. So x plus 2 is also a factor. To finish, I'm going to write the complete factored form. So what I did is I took one factor. I chose to use x minus 5 first. The polynomial that remained was 1x to the second power plus 3x plus 2. This trinomial can be factored. The two numbers that multiply to make 2 are 2 and 1, and those two numbers also add up to make 3. So the complete factored form is x minus 5, x plus 2, and x plus 1. Notice we found x plus 2 to also be a factor, and that was a factor within the polynomial's factored form.